Hello everyone. From today onwards, we will be learning engineering mathematics. And in that, we are going with the linear algebra. So let's get started. Linear algebra, the branch of mathematics that deals with the theory of system of linear equations, matrices, vector spaces, and linear transformations. And in that linear algebra, the first topic what we are going to study about is matrices. And matrices has a wide range of applications in electrical and computer science. And anywhere we need to solve complex order problems, there we can use matrices to simplify our problems. Okay. So what matrix is? Matrix is a set of mn numbers, either it is real or imaginary, arranged in the form of rectangular array of m rows and n columns is called an m into n or m by n matrix. An m by n matrix is usually written as like this shown in the right form. Here this is called the array. We can represent this total complete as A11 ratio AMN. Okay, these are called arrays, and the including part here, these are called element of matrices. Okay, these are called elements of matrix. A11, A12, A13 are all are elements. And how we can represent matrix? Matrix can be represented by this capital letter is used to represent a matrix and equivalent to this whole bracket and this small element aij. Ij shows the position of the element inside the matrix. I shows the rows and j shows the column. Okay. And here after the bracket we represent here the order of the matrix m by n. This represent the matrix as a m order and m row and n column. Okay, so we can simply represent this as a equals to bracket aij and bracket close. So first, inside the matrix, we have types of matrix. There are variety of many types of matrices present, and we are going to learn about each of them. Okay. The first matrix here is the row matrix. Row matrix simply we can identify as one row matrix having one row and n number of columns. So we have to limit the rows and don't worry about the columns. Okay. So here it is showing the row matrix. Elements are A11, 12, 13. You can see here rows are fixed. First row, first row, first row, first row, first row. And columns are infinite, whatever we have requirement according to that. Next is column matrix. And column matrix is simply like row matrix. We have only one column in the column matrix and represented as m by 1 order. Okay, here m is the number of rows and 1 represents the number of column, that is 1. Here this represents the column matrix. Okay, now we have square matrix. In square matrix we have the matrices have a value of m equals to n order, where m represents the rows and n represents the columns. So in this square matrix, rows will be equals to the columns. Okay, like this. There are 3 rows, 1, 2, and 3, and 3 columns, 1, 2, and 3. Okay. Next we have diagonal matrix. Diagonal matrices, all elements except the leading diagonal elements are zero. The important part is leading diagonal element for this diagonal matrix. Or this is also called a principal diagonal elements. The leading diagonal element should be the number, and except that everything else will be zero. Every element will be zero except the leading diagonal element. That we call the diagonal matrix. Then, but before it should be diagonal, it must satisfy the condition that this matrix should be a square matrix first. So the definition says the matrix should be first a square matrix. Then after that, all elements except the leading diagonal elements are zero. So this is a square matrix, and these are leading diagonal elements. There are some values, and after that, all except every other values are zero, 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 and zero. Next, we have scalar matrix. This scalar matrix can be defined as the first. It should be a square matrix having m rows and n columns and equal rows, equal columns. Then second it should be a diagonal matrix. Okay, so leading diagonal element will be there and others will be zero. And the third will be all the diagonal elements should be equal. Then it will be called as scalar matrix. Okay, so here represent as diagonal matrix with equal elements. So we can say the C like 4 4 4 5 5 5. Any value can come here, and but that should be equal, and the matrix should be a square matrix. Okay, or diagonal matrix. So we can say that this scalar matrix is a diagonal matrix and is a square matrix. Okay, scalar matrix can be will be a square matrix, will be a diagonal matrix, but it doesn't means that every square matrix will be a scalar matrix or every diagonal matrix will be a scalar matrix. Reverse is not possible, may not be possible. Okay, let's go back, go to next slide. Where next type is identity matrix. And now the first three conditions would satisfy before we define it as identity matrix. And first three conditions are what? That first it should be a square matrix, then it should be a diagonal matrix, third it should be a scalar matrix, and after that the scalar value should be 1. Then we will call it as identity matrix. Okay. Next, we have null matrix. Null matrix, as the name represents, it has nothing, null elements or zero matrix. Means that every element of this matrix should be zero. Then we will call it as null matrix. Then we have triangular matrix. Triangular matrix can be upper triangular or lower triangular. In this matrix, we should define it as the matrix in which the values above or below the leading matrix are zero, and others opposites are there are some elements present. So for example, I have shown here the upper triangular matrix. Here the values below the leading diagonal are zero, and the values above the leading diagonal are present and with the leading diagonal value. So this will be called as the upper triangle. And when we have we will have the values like A11 and A21, A31, A32, and A22. These values will be present. Then we will call it as lower triangular. Okay, lower triangular matrix. Next type we have idempotent matrix, in which the condition is the product of two similar matrices gives us the same matrix. Then we will call it as idempotent matrix. A square represents here A into A, or multiplication of A matrix into A matrix will give us A's simply. Okay, so these two matrices are example of idempotent matrix. I'll show these multiplications in coming videos. Okay, when we will learn about the multiplication of matrix, we will do this also. Okay. Next, we have involuntary matrix, in which same as idempotent matrix, but here the equivalent will give us the identity matrix. Okay, when we multiply matrix with the same matrix, it will give us the identity matrix. Here, like this, a square matrix having diagonal elements as 1. Okay, let's go to next slide. Equality of matrix. When we can say that two matrices are equal, two matrices are equal if they are of same order. Means that they should be of same order, like m cross n, and here also it should be m cross n. And all corresponding elements are equal. Means if first value of this matrix will be equals to the first value of this matrix, then we will call only then we will call these matrices as equal. So every corresponding element should be equal to identify these matrices as equal matrix. Okay. And how we solve use these matrices as when two matrices having different equations can be solved by equating each element with corresponding element. Like these, we have two matrices. This matrix represents the equations. Here, this element is the equation. This element is the equation where x is unknown. Here, x is unknown. Here, a is unknown. And in this matrix, there are values, and it is equal. Said that the two matrices are equal. So we can just equal these element and find the values of unknown x. Okay, so like x plus 3 equals to 5, so x will be given as 5 minus 3 and will be 2. So that can be solved through this property of matrix, that is equality of matrix. Okay, so let's go to the next slide. Properties of slice matrices. Properties of matrices. Matrix addition is associative, commutative in nature. What associative means? Associative like this: A plus B plus C, where first we add B plus C, and then we add A in the addition of both, the result of these B plus C. So this will be equals to the A plus B and plus C, where we add first A plus B and then add C. So this is followed by a matrix. So okay, commutative, what means that if we add A plus B, uh, this is like alignment. The first element, first matrix will be A, second element will be B, will be equal to the same B plus A, where first element will be B and second element will be A. And same case follows with matrix subtraction, as these values minus sign with these values just go inside the bracket with the matrix. Okay. Next, we have matrix multiplication is associative, means it follows A, B into C and A, B into C, where we multiply first B into C and B, C, and then we multiply the result with A, which will be equals to the when we multiply first A and B, and then the result will be multiplied by C. The result will be equal in both the cases. So it means that matrix multiplication is associative. What means distributive? Distributive means when we A into B plus C, where B first we add two matrices B plus C, and then we multiply with other matrix. The result will be equals to when we can do the multiplication and addition afterwards. First we multiply A into B, this value to this, and then we will add A into C. Okay, then this is called the distributive law, where we have distributed this bracket values. Okay, but not commutative in nature. Matrix multiplication is not commutative in nature. Here matrix addition was, but matrix multiplication is not, because a into b, when we product these two values, the result does not come b equals to a. Okay, if these are separate elements, if these two matrices have different elements, the multiplication does not follow the commutative property. Okay, commutative law. Let's go to next slide. Okay, so coming topics which we will learn in the coming videos, that we will learn about multiplication of matrix and step by step how we multiply the matrices, and transpose of matrix, how we transfer the rows into columns, and symmetric and skew-symmetric matrices we will learn about, and then afterwards we'll learn about determinant and inverse of matrices, and by different methods, etc. Okay, so share this video to your connections for their benefit. Okay, I hope you like it. Thank you. Thank you.